welcome to the last talk and track Terrified Chipmunk. This is going to be a little interesting because the operator and host are in the same room and we don't want audio issues, so we're doing our best to mute and unmute. But this is going to be a great one. We have Flavor Flav, aka Tyler, and Aaron are going to be going over the badges adventures for this year. So real quick, gentlemen, given, I know some of the backstory, given the interesting adventure you guys were on, are you still going to do badges for us next year?
Yes, I think we're going to do badges again next year.
All right, I will take that as a yes. Gentlemen, have a great talk here, and if anybody has questions, throw it in the Discord channel and I'll ask them at the end. Thanks. Take it away, guys.
All right, yep, audio's working, cool. So sorry about that. It's a little bit interesting as I try to speak and operate the stream and work with Jason as we host things. But my name is Tyler Rosonke. My handle is Zonksec, and with me is Aaron.
How's it going, guys? Scotch Zek here.
So we built this year's badge, and we also built last year's badge with the help of Jerry. So we're just gonna jump right into it. We're gonna start with the inception of the idea. So it came about 218 days out from when Kernelcon was supposed to happen. We had a Google Doc where we just were throwing in ideas of things we wanted to do. We had the theme of vision established, so we had different ideas related to sort of eyes and glasses and, of course, corn. But then Aaron actually posted what you see there on the side. And at first, we kind of liked the idea, but we also had some other working ideas that we liked, so we weren't super sold on it. But then we discovered that you could actually get custom reels made. And at that point, we're like, oh my God, we need to do this. Like, custom reels would be sweet. But we had to figure out how it was gonna work. Was it just gonna be the shape of a Viewmaster? And then once we figured out that we could get reels, okay, now it's gotta hold reels. You know, or we get a 3D print some components or something on the back to hold the reel, or what could we do? And then, you know, even if it holds the reels, are we gonna try and magnify the images, or are we gonna have them just have a hole and look into the light or window? How is this all gonna work? And then we had the thought of backlighting with LEDs. And so I started playing around with that. I took the year before's badge and I placed, an old Viewmaster reel on top of it, and it didn't look super good. Like you can see, the LED was just super, concentrated, and it didn't light very well. And then I took a piece of printer paper and threw it over the top of the badge, and it diffused the light. And at that point, we're like, this is awesome. We need to do this. We want to backlight them. How are we going to hold the reels? Then we kind of had the idea based on what badges we've seen at DEF CON of taking nylon studs and building a double layer PCB. And if we put those studs in the perfect spot and put the holes in the PCB in the perfect spot and the LED backlights in the perfect spot, we could line all this up so that there's holes in the front of the board, it's lit perfectly in the back, and when the reel is inserted and hits those studs, it's in the right spot. And so once we kind of thought about those constraints, things started to take shape. You can see here some of the first iterations of me attempting to lay some things out. Obviously, we wanted it to have the shape of a Viewmaster, but we kind of had a lot of spatial challenges with doing this design that normally when you're making printed circuit boards, you throw the components on, you wire everything up, and it's in a square form factor and it's done. But With this, we got to do all those things, but the form factor matters, the shape of the outside, where the parts go. We didn't want through-hole components to be where the reel was going to be because it could snag and potentially scratch the reels. So we had to make sure all the through-hole components would be away from where the reel is. We needed to make sure that there was room for you start scooting through-hole components away. We had to make the design wider so that we could put SAO mounts and things where they need to be. So yeah, in general, there was lots of spatial designs, and so we had to go through a bunch of different ideas to come up with it. But once we had one we liked, we had to sort of get that into our PCB design software. And for that, I use Eagle. It's an Autodesk product. And last year, we had some challenges with getting sort of graphics and shapes into Eagle. Like, it was kind of tricky. And I think it was during a boot screen of Eagle or boot screen of Fusion 360, which is Autodesk is the company that makes both those pieces of software. I saw them promoting a new integration. I don't know how new this was, but I noticed it for the first time. An integration between Fusion 360 and Eagle. And that's awesome because Fusion 360 is like a 3D modeling software, and I was familiar with it from 3D printing. So the fact that we could do graphics and spatial things in a piece of software that's designed to do 3D modeling and then move that into Eagle was awesome, because Eagle is very, very good at schematics and placing parts in small amount of boards, but anything beyond that, it's kind of clunky. So this integration with Fusion 360 really unlocked a lot of things. And an added bonus was all of this laying out I was doing in the previous slide within Adobe Illustrator. I could export vectors straight into Fusion 360 and then do an additional manipulation there and then back into Eagle. And so it kind of like fit right into the workflow. So from that point, we have our boards laid out. We know exactly what things are going to look like. We just kind of had to put together a design. And so we went with an Atmega 328P AU, which is an Atmel chip. And the reason we went with it was because it's actually the chipset that's used in Arduino Nanos and in Unos, but it's like the through-hole version. It's not a surface mount version. And the reason that's nice is you get the Arduino family of libraries and tools. So that kind of enables us. So that's nice. The LEDs we use are APA 102Cs. These are addressable LEDs. We kind of went with those because we had experience with them last year. And the nice thing about addressable LEDs is you can, they chain together in a bus. And so for limited I/O on a board, you can run a lot of LEDs. And that was especially needed last year when we were using a chipset that didn't have a lot of I/O. This year, we probably could have gone with something different, but because we were familiar and we had parts left over from last year, it made sense to use them again. The other thing on the board was a momentary button to change the modes, SAO things, an unpopulated pads for some CTF challenge type things, and then we had to add what we were calling, and I don't know if that's an industry term or anything, but interconnect. We had to share power between the top board and the bottom board in order to power everything and run the LEDs on the back too. So with that design, we could
point this out. But I think it's a good time to point this out, but our cost constraints on this. So if you've been to DEF CON and you've seen like the crazy badges from And.Xor or those other types of badge builders, you'll see that they'll have a lot of expensive parts on there with a lot of buses and a lot of other things they can use, which it's a conference badge. So we don't have those kind of funds. Like they can basically make a badge for $60 and sell it for $120 to an attendee, and everything's fine. When you know, for us, we're trying to keep our costs down as low as possible, to like a $15 a badge or something like that. So that definitely goes into the equation on picking the parts and how this is going to kind of come together.
Yeah, good point. I'm glad you threw that in there. So at this point, we have a design. Let's get a prototype. So 190 days out from Kernelcon, we ordered our first prototype, and we ordered it from a company called JLC PCB, which is a PCB manufacturer based in China. We used them last year, and it worked great. So we started with them again. So this is how it arrived. For those of you that aren't super familiar with how surface mount components go onto a printed circuit board, this is a quick kind of demonstration of how we build them when we're in the prototype phases. You essentially get this board that's unpopulated but has all the exposed copper pads for parts, and that all gets designed in the software that you make your design in and then send off to the manufacturer. So you get it. It looks like this. And then the great thing about surface mount components is you can solder everything at once using paste. So you can see there on all the little pads is a little dollop of solder paste. And so I went with a syringe, pad by pad, and populated everything. And then I used those tweezers there on the right to place the parts. And then at that point, you just need to put it in a special oven to solder everything. And I don't have a special oven, so I use a toaster oven that's been modified with another Arduino to follow a precise temperature curve to make sure that the solder flows and solders all the parts, but you don't want it to get too hot and delaminate the board or ruin any components. So that's why you have to have a kind of specially controlled temperature system. So pull it out of the oven. Even the oven knows that our badge is fire, it's super hot. So once it's all soldered together, it's time to start trying to program it and see how everything works out. You can tell from the get-go it's a little bit sketch because there's an extra wire going from the Arduino I'm using to program it, and that's like an extra ground. We had some ground issues. And even with that corrected, there was an error. In the data sheet for our chipset, it mentioned an internal clock. And for whatever reason, I could not program it. I kept getting weird errors that when I was trying to debug it, all seemed to come back to an issue with the clock. And so I thought, well, we don't have a clock, it's internal, but maybe for whatever reasons, in order to program it the way I knew how, it needed a clock. So I busted out magnifying glass and soldered 2 wires that were far too big for the job onto the pins that needed to add a clock to the chipset. And then I put those out onto a breadboard where I put a clock. And from there, I was able to actually program it. And once I was able to program it, I could tell it, hey, use your internal clock next time. And I didn't need the wires anymore. There might have been a way to actually get around that with the programmer, but I didn't know it and I couldn't figure it out. So like all good hackers do, I kept trying the things and figured out a path that worked for me. So with that, a little bit of hackery, we had it working. You can see that there's that ground issue again on the bottom on that white wire, getting the grounds working. But other than that, it was good. Oh, I'm going to go back one slide. If you look at the reels, you can see they're again, the LED is like super concentrated and it doesn't illuminate the picture well. And I put a piece of printer paper behind it. You can kind of see it there on the reel. I don't know if you can see my mouse. Oh, you can, sweet. But that didn't help. And that's when I had to get a little bit more crafty. So 173 days out from Kernelcon, I started playing with diffusion and math. So the idea is I need to get that paper far enough away from the LED so that the LED isn't super concentrated. But the question is, how far do I need to go and try to be optimal to keep the boards close together? Because if the boards get too far apart, then our interconnects have to be really long. So we want it as close as we can get it. So we can do that with some trigonometry. So I measured the reel, and they were about 12 millimeters wide. And then I looked at the data sheet of the LED and found that the beam angle from the LED coming out was 120 degrees. So I could have busted out an old trigonometry book and tried to reteach myself, but the internet exists. So I found a triangle calculator, pasted in the parameters I knew, and because we had the 120 degree angle, we know that these two angles are 30 degrees, and we know that this side's 12. And then from there, the triangle calculator could figure it all out. And the height of the triangle was 3.4 millimeters, meaning if the piece of paper is 3.4 millimeters from the face of the LED, that would give the light enough time to get out to the correct width needed to properly illuminate the real image. So I took some double-sided tape, stacked it up to get it to the right distance, threw on that printer paper again, cut it down to size, so you can see it there on the left. And then sure enough, toss the reel in and you get a perfectly illuminated picture compared to the one on the right where it's all concentrated. So I had a little dance party with Sesame Street to celebrate that success. The beauty of Pogos. So I discovered last year when we programmed everything, there were we had socketed chips that I had to push into every single badge. So programming them meant taking it out of the sleeve, bending the pins so I could put it in my programming socket, programming it, taking it out, putting it in the badge. And that is a lot of moving parts, and it's not very fast. The reason we did that was we wanted people to, instead of having a badge that sits on the shelf that they can't do anything with, they could take the chip off and use somewhere else if they wanted to, was the original thought. But it comes at the cost of a lot of extra time. And so what we discovered are these things called Pogos, that they're kind of like a spring-loaded pin, much like a pogo stick. And what's awesome is that you can get a really good contact that is temporary. So you could basically take the Pogo's programmer stick and push it down, and those springs will compress and it'll make good contact. And the tips of those are conical so that it makes good contact. So you can push that thing down, program, and let go and be done. And that was going to save us a lot of time. So at this point, we were ready for our second prototype. We had those ground issues, if you remember, and we had some other changes that we wanted to do. So 169 days out from Kernelcon, we order our second prototype. And again, we got it from JLC PCB. So the big things we wanted to do is add in that crystal so that I didn't have to do my hackery to get the program on it. We wanted to fix the board ground issue, and then we relocated where the surface mount, where the SAO header would go, because where it was going to interact with it's going to hit the lanyard, so we had to move it. So the picture on the right there shows the new fancy clock that wasn't there before, or crystal, I should say. So at this point, we hadn't ordered reels yet. I was just using vintage stuff that I had. So 147 days out, we started looking into that. The first thing I got was some samples, which was interesting. I called the manufacturer I found to ask him some questions. I was curious what color of, you upload images, and I was curious what color becomes transparent. Is it whites? Is it blacks? Like, one of them is more transparent than the other, and I can tell by looking at the reels, the vintage reels, but I didn't know if they're processed different. And the lady I got on the phone was pretty confused why I was asking these questions, and it was interesting when she found out that we were like building our own viewer kind of a thing, and it was a funny conversation. But she's like, I'll just send you samples. And so a few days later, I had some samples in a viewer. And from there, I learned that the transparent layer that I had to upload an image was white. So the original plan was I was going to make a pigpen cipher that would layer on the different reels. And so I would just make the background white, and then you could layer them and the transparency would be there, but the black would come through. So I did that and I ordered them and I just put some memes in there temporarily. And this is what they ended up being. Wasn't sure if we were going to change those later or just keep the memes, who knew. But I ordered them and they arrived and they looked okay. I mean, not super great. The text was super small. So some of those memes weren't going to work. So that was a lesson learned. But ultimately it was a fail because the layered idea just like didn't work due to maybe discrepancies in their process, or for whatever reason, it was super hard. Like I made the cipher and I couldn't get the things to line up so that it was distinguishable like I thought it would be. And so it was no good. And we ended up kind of just scrapping that idea. And around this time, I saw like a vintage computer ad that I thought was funny. I think it was the center bottom one, this one. You know, it was funny because it's outrageous how much that is for that, given what, you know, the cost is today. But it said the hard drive you've been waiting for. And I kind of had the thought like, well, what if it was the hardware hacking village you've been waiting for? And that kind of sent me down a whole path of designing sort of these things to go on reels from vintage computer ads. And we ordered those, and that's what ended up being what we went to production with. So I'm going to hand it off to Aaron now. We kind of broke this whole thing up into I build the design, and Aaron has input there, and then he kind of handles all the logistics. And so at this point, we're kind of switching gears where the design's kind of wrapping up, and now we need to figure out how we're to get this done. So I'm going to hand it off to Aaron to take it from here.
All right. So the title of the slide's Overconfidence. And there's a reason for that. Rosonke and I met really often, honestly, on this badge. We're very collaborative effort on everything. And about 85 days till Kernelcon, we're talking about it, saying, okay, we're gonna go ahead and we're gonna prototype in January. At this point, we're looking at doing a full assembly with a new place that we've never used before called PCB Way. They come highly recommended by other like DEF CON badge builders and things like that. So they do what's called a full turnkey assembly, where they're able to source all the parts, manufacture the PCB for us, and they're able to deliver a finished product, so to speak. And that's what we're hoping to do. So we're thinking, okay, well, 85 days until Kernelcon is right around January 1st. It's about the time this is happening. We're into December. So our plan was, again, January prototype. February, we'll go ahead and do like kind of the final assembly along with the actual production. And then the March, we'll kind of wrap everything up. We'll be good to go. In fact, Zonk scheduled a ski trip. I actually put in for a week-long SANS course the first week of March that thankfully didn't get approved because all of our first quarter of training didn't get approved. And then, yeah, that's pretty much where we were. We go ahead a slide or two. So yeah, that's what we're looking at. So we'll go ahead and we do this third prototype now. So we've switched companies. Our first two prototypes were the one we used last year, we had a lot of familiarity with, JLC PCB. In most cases, they're an 8-day turnaround. Basically on a Monday, if I'm going to go ahead and drop a file for a PCB production, I'm going to see it the following Monday on my doorstep. They do a great job. But again, we went with PCB Way based on a lot of input from other people. So 82 days. We put that in. 2 weeks before Chinese New Year, thinking we had time. For those not familiar, China shuts down in normal circumstances, normal years. Obviously, this isn't one of them. For a week for basically about 10 days at a time. This year was like the 19th to the 31st, I believe, is what it was. 10, 12 days was the traditional Chinese New Year. So nothing really gets done then. So we're hoping we get our prototypes in before then. And if we skip ahead here so here we are. That's the date they processed the order. This is the prototype. This was 5 badges, by the way, for $346. This is what happens when you buy the parts at the same time in a very small batch order. And we went ahead. So we have it ordered, we think everything's fine, and then, I'm not hearing a lot, and then all of a sudden, I'm seeing on their website on my order status that I'm expected to see this like the 11th of February, I believe they put in there. So I'm like, hey, is there a way to get these faster? You can see the email they sent back to me saying, ironically, there's one component they have to actually source from the United States, which was actually really funny. And we had 12 emails kind of back and forth, and we were going back and forth on this a lot. And we're starting to get a little worried because Chinese New Year's coming up. It's another, week and a half out of the schedule. This is a full turnkey operation. This is just the prototype. We still have to have time to actually not just make sure that the prototype we sent them works and correct any issues with back and forth there, but also do a full production run of PCB manufacturing.
And something to note here is we had never worked with a full turnkey assembly house before. Previously, we got PCBs made and we found somebody locally and we did all the logistics to get all the parts. And so we were kind of in the middle of that and figured it out. But, doing full turnkey has its own complications. And so we had to end up working with their engineers for them to kind of like approve our PCB. And like that previous slide said, there was tons of emails and like the clock's sort of ticking away and it's not moving. And so we're kind of freaking out a little bit. And I'm going to move to the next slide for Aaron.
Yeah, but this next slide definitely illustrates the point you were making too, where, it's basically, we're looking at, December 13th is when I started talking about the order. It went through basically, I think the real date I pushed it through was, I think, the 28th, if I recall. They put it into production on their screenshot like we showed earlier on like the 3rd. And then suddenly I get this estimated delivery of Feb 11th, which is not cool. So we're starting to get worried. And worried's putting it lightly. We're looking at...
It's January 8th when we kind of do this assessment of, okay, we ordered about a month ago, things aren't moving. It's going to take a month to get our prototype back. So it's in total, that's a 2-month process. And after that, we need to get 400 of them or whatever the number ended up being, we weren't sure at the time, in a month. So it's not looking good, right? Like they're going to have to go double speed than what they're doing for a order that's, 400 times what they're at.
And what we should clarify about what they're actually doing for us is that, the badge you have right now, and I have all of them here, because why not? We're going to bling out today like Zon. You're seeing a sandwiched PCB. Well, they're not going to give us that. They were literally going to put what they call surface mount parts on the badge that are like the LEDs and resistors and things like that. And then we're going to get those and actually we hand assembled those nylon nuts and bolts. So, and along with the battery pack and any through hole soldering that 4-pin interconnect that we talked about before in the parts. So that takes us time. We normally do, we'd want at least a week or two at a bare minimum to get that done. So you can see on the next slide there where we're starting to freak out a little bit. Things are not great. So now we move on to what we call our assembly crisis. This is where we're basically giving up on PCB Wave. We don't really know what to do. Our lead times are not amazing with them, obviously, but we kind of put all our faith in them too. Our eggs were kind of in one basket at this point. So we talked to the guys that helped us out last year, and BA Engineering. These guys did awesome, because to be in full disclosure, we had actually thought that we couldn't afford them this year because they're US-based assembly and they're great dudes. But we ended up being able to afford them anyway, and they bailed us out, which was awesome. Thanks to Jacob and Matt, and they did awesome to help us out here. So now we have assembly. That's only half the equation. We still need to have the PCB manufactured. So we have half of our issue solved, which has also spawned new problems. So, we're looking at another, so now we have to put PCB into a panel. And the reason we have to do this is because when you've done small batch manufacturing, that VA engineering can do, like what Zonk's bring right there. The panel.
Here, I'll talk to the I take priority. So this is what a panel looks like.
And that's used because that panel is going to go into a machine called a pick and place that puts the parts in its place. We have video in a little bit here to show you that, some graphics, but that's for essentially assembly efficiency. So without that panel, it drags on even longer to do these individually. So we had to create those engineering files with BA Engineering to fit their equipment. And then we went ahead and we went back to JLC because they were kind of our buddies. We've used them for a long time. We trust them. So we went ahead, and the next slide shows our initial design. Well, it failed their review, unfortunately. Yeah, we had some engineering issues. We fixed it. So 4 days later, now we're down to 60 days to Kernelcon. This is why we started showing those days. It's going to get very important very quickly. And my coworkers got to hear me complain about this on a daily basis for quite a while. Sorry, guys. So we put it in JLC now. Keep in mind what happened 60 days ago in China. Yep, that's what happened. So now you can't get PCB. We've been ordering parts. We've solved assembly, but we don't have a way to actually assemble anything because it doesn't exist yet. You've got to have that key piece, the PCB, which is the badge itself. So now we're in limbo. We can't do anything. So what are we doing? So now we say, okay, let's pivot. Let's try and use a US PCB manufacturer. So hit some up. I talked to several, kind of have a nice little rundown of our experience with that here, where, one vendor, and I'll leave these guys nameless, even though I'm very upset at them. They gave me a quote very quickly, within I'm thinking 6 hour turnaround. But then they wanted me to call them, so I called them, and they said, "Hey, we were wrong. The guy that created this quote should be written up or fired. The price doubled." I don't know if that's necessarily because they thought they had us over a barrel due to the crisis in China at the time, but I'm not saying it's not the case. I don't know. So, but they did promise a 5-day turnaround, which was encouraging, providing we could afford their price, which was well over 10K. Actually, it was more like 16K if I recall, just for PCB. Second vendor, I literally had to call these guys nearly daily to get numbers out of them, and it was driving me nuts. That they finally gave me a quote, and then they actually gave me an even bigger price than the first vendor, but they did promise a 2-day turnaround, which could save us. But this isn't looking great, obviously, at the moment. Meanwhile, while this is happening, and we're not barely a month of Kernelcon, everyone remember PCBWay, our full turnkey? Yeah, they finally came back. They finally delivered on the 18th of February. Well, we ordered our first prototype. That took literally 2 months. So I'm glad we pivoted away from these guys. So now we finally get stuff out of JLC. So we went from 60 days we ordered out to now it's 26 to 34 days to get this prototype panel. And part of our constraints when you're doing this is that every time you make a change on any of those engineering files for PCB custom manufacturing, you have to or should prototype. If you don't, and you go to production and you do a full run, you can have 600 bad badges. And so every time we made some minor changes, we had to change we have to put in a panel. I think we made one tweak as well. So we had to wait for that to even know that we had a viable product to go to full production with. So now they're here. It's 26 days until Kernelcon. At this point, I don't have PCB because all I've got is prototype. And we've had all these extended lead times. It's taken 34 days to get those panels. I mean, PCBWay took 2 months to get everything. Shit was not great, put it lightly. I drank a lot of this, Ardbeg, in case someone's following along. And, it is what it is. So we kind of had this kind of crisis meeting where we were literally set up to have a call that evening to discuss with some of the other Kernelcon organizing members, what the hell are we going to do for badges? We were looking at a lot of different options, and so where we're at right now is that US-based PCB was just ridiculous. We couldn't do it. I mean, I would love to have everything made in the United States, don't get me wrong, but for a small conference in Nebraska, trying to do something cool with not a lot of money, it was beyond our means. There's no guarantees it would work. We couldn't prototype. Every time you switch manufacturer, you want a prototype. Like I said, that's like I was saying before, you don't want to introduce problems into production. JLC, we knew at the time, they had great status updates, but they weren't looking great. They were getting gradually better, but they were trying to, they're always out there saying, hey, we're getting a little bit better. Things, lead times kept starting to shorten, but nonetheless, we don't know if they'd be able to deliver in time. So we had all the parts. We had BA Engineering on board to do at least that surface assembly for us, but we had no PCB. So we even had a plan W, we called it jokingly. Plan for wood, obviously. We do wood. We just put on laser cutter and rock and roll from there, because we basically figured we just, all the parts we bought and everything, we would just push the next year and figure it out then. However, that exact day, JLC PCB is back at full production. All 6 factories of theirs. We got that like 2 hours from the meeting this happened, I think. So kind of a real odd last minute twist for us of all of a sudden, should we chance it? So we said, why not? So now we go to full production order. Took us a couple days to get everything in order with them. 23 days till Kernelcon, we pull the trigger, and we'll see. We just had a 34-day lead time with these guys. So if we don't get it at least a week before Kernelcon, at the latest, we need it honestly 2 weeks. We were pretty much sunk for electronic badges this year.
And our thought was, even if they show up so late that we don't have time to put parts on them and we don't have time to put them together, we could still break them out, and it's cooler looking than the wood would be. So it's kind of like, it's still okay if they show up super late. It's better than the backup plan, but not ideal, obviously.
Yeah, we were basically we basically went through all these series of bargaining with ourselves on contingencies on what we would actually accept as a badge. It's basically what was happening. It was getting interesting. So JLC came through though, 13 days until Kernelcon. So this is important. Normally this is a 4-week process. We'd want 2 weeks for the surface assembly with our assembly guys, BA Engineering. And we want at least 2 weeks for we have to program every badge. Well, we got Pogos, like we talked about before, which made it way awesome, by the way. But nonetheless, there's still hiccups there possibly. We'd have to do quality control of any issues of part of that assembly, and actually hand assemble, turn every single little nut and screw on here, and solder every joint that was a through hole, like the interconnect and the battery pack ourselves. So that's not a lot of time. So BA normally needs 2 weeks. Oh, 10 days. Sorry, I'd forgotten that. Because now we're a virtual con, because when this happened, we went virtual literally 10 days before Kernelcon, something like that, 11 days. So we didn't even know what was going to happen because of everything that was happening at the time. So much was in so much constant flux. So here we are, 10 days before Kernelcon. We're trying to get this done. So BA again saves the day. And we have some neat kind of graphics here on that process of what they did. And they called it the American Sweatshop. It's 2 guys in the basement, literally doing this from I dropped it off at a Thursday evening, and we had them by that Sunday evening. I think it was Sunday afternoon. We had everything completed, which was insane because it took them 2 weeks last time for less panels, just due to just how new everything was. And the parts are different. Things are a bit different on this one. I think it was actually easier for them. But yeah, it was interesting. So that first one you saw was putting on the solder paste, where the solder's going on to every pad on the board so the parts can sit on it. And that's what actually, through the heat, will actually glue the parts to the board, essentially. It's just solder paste. From there, that board with the solder paste is going to have the actual parts put on. That's called a pick and place machine. So that's programmed specifically to understand the coordinates and orientation of every part and place it in the right spot. If this goes wrong, if it's programmed wrong, I'm going to have 600 badges with LEDs upside down or whatever it may be, right? So this is really critical.
And if you're wondering what the light is, it uses optical recognition to know if the part needs to be turned. So if it's kind of like a rectangle shape, or even if it's a square shape, it still has pad definitions on the bottom. Using the camera and the light, it can know what direction it's in and rotate it if it needs to.
And from there, it goes to the oven. We jokingly call it the easy bake oven. If you were at Kernelcon last year in the hardware hacking village, you saw Jerry owns one of those, and it's kind of a small scale version of this. This one's a little more upscale. It's got a nice conveyor belt, bigger capacity, obviously, more features, but that's the badges coming out. So we're moving. So we got those, and all of a sudden, after that heroic effort, quite frankly, from BA Engineering, we now have 7 days to get these things together, which surprisingly worked. So here's everything assembled. This is how it was delivered to Zonk's house. That's all the badges. Front panels, back panels. Actually, there's another box besides this, isn't there?
No, this is there's a little side box, but this is most of them.
No, this is mostly assembled.
So
now, Zonk had a genius idea. I'll let him describe this. This saved us a lot.
So we talked about having those Pogos, which is nice, but it takes about 30 seconds for the bootloader, and maybe like 20 seconds for the bootloader and the program to flash. But with those Pogos, I'm frozen, right? I have to hold that for 20 seconds. So I could be, if I didn't have to do that, I could be, breaking these out or doing some other task instead of just sitting there waiting. So I wanted to make a clamp, and they make clamps, but they're kind of expensive. And then I realized I could buy just these like Pogo pins. So to put it in perspective, the thing I showed early on to do the programming, I think it was like 20, 25 bucks or something. And I was able to buy 100 of these Pogo pins for, I think, $6. And then from there, I could use a prototype board and then a hacked up clothesline pin and get these pins in the right spot so it could clamp. And I had to get a little creative on how to get those pins to be the correct depth, because if they're not deep enough, then the pins aren't going to be compressed and it won't make good contact. So I took the prototype board that just has holes in it that those pins can slide through, and I put another one underneath it so it's slightly higher, and then I put the board that it's actually going to program underneath and let the pins fall where they need to be so that alignment's right. And then I could solder in that top board, and when I removed that sort of bottom board that acted as a spacer, I had about whatever that thickness of that board was of compression, which was the perfect amount for those pins. So now I could just take these closed pins, snap them onto the board, and it would program, and I could go do other things. And I made a second one that I don't have photos of to program the backboard, or not to program the backboard, but to test the backboard. So this one you see in the pictures programs the front and then powers it and then runs, it turns on. And so we can very quickly, before we solder anything onto these, before we put any of the nylon bolts on, before we do any of the extra work, we can say, is this PCB any good? Did a LED put on sideways? Did it not make full contact? Did it just get too hot in the oven? There's a lot of things that can go wrong in the assembly process. So if we don't do any of that testing and we go straight to assembly and spend all this extra time on something that was already broken, that's a huge waste of time. And so I built as many testers as I could to test functionality on the back, or sorry, on the front that's around me, and the panels that are on the back. That way, when we actually, we don't waste any time. So this is an example of my dining room, which is actually where Jason's been presenting all day from. We had to break all of the boards out of their panels. For the backs, we had to solder on the battery packs. For the fronts, we had to put nylon studs in there, and then we added the double-sided tape and the diffusion paper to the backs, and my wife helped out with that, even with her broken hand. So huge thanks to her.
Trip you got when we were overconfident.
So huge thanks to her for doing that. And then we ran into other challenges. So after we cut those things out, we put the boards together and soldered the interconnect, and they were done. But we got through all the hacker ones, and then we got to the lesser quantities of speaker organizer and things of that nature. And the way we break them out of these panels is they have these things, I think they're called rat bites, which are basically just a series of drill holes that you can snap. And one of our panels didn't have them. I should say one of our types of panels didn't have them. So it wasn't just one, it was, I think, 6 or 7 panels that didn't have them. So what do hackers do? Hackers gonna hack. So I busted out the jigsaw and cut out every connection. So the outside here, and then in the middle and all around. How to make do. And then we took files to make sure it wasn't sharp. So then just kind of another shot of our workspace. You can see the fronts there, right here with the studs sticking out. And then the backs here that have the battery pack soldered on and the spacing and the paper. And then we would basically take those two things, set the interconnect in on one, marry them all together. So you're trying to get 4 studs lined up, and then 8 pins on, 4 on one, 4 on the other for the interconnect, and you kind of like shimmy it all together. And when you get in a groove, it's pretty fast. But at first we were struggling, and we're like, oh my God, how many of these do we have to do? But once we got a groove going, they flew together. So we were actually able to, more things can go wrong. So the buttons to indicate, to move to the next mode, kind of had issues. I don't know if it was in transportation on the boxes rubbing together. Some of them were just melted in the oven. But the little rubber that pushes down on the contacts would either fall off or melt away. But that's nothing a little hot air couldn't fix. So we had a rework station to basically remove the bad parts. And then, so you get it hot, take some tweezers, pull off the bad part, clean up the surface, put some new solder down, and then you can basically just work just one section of the board. So something to note is that you pretty much plan on 10 to 20% of your badges being bad. Whether that happens at the PCB assembly state, just getting the boards made, versus at the state when you're putting parts on the board. Like I said, things can get on backwards. Lots of places things can go wrong. Maybe on the Mega chip, like there's too much solder paste and the legs joined together. That could happen on multiple parts. Lots of reasons why things just don't come out right. And they're all fixable. But the issue is you typically don't have time. And sometimes the issue isn't obvious. So it's not worth you spending, 45 minutes trying to fix one when you got other ones, to go. So you pretty much, you order 10 to 20% extra so that when you're putting them together, you just toss them in the pile and say, we'll fix them later if we need them. And so that is our dead pile there. And when we did the numbers, it was about 11% this year were unusable. And I should say 11% of either front or back panels. So it's kind of not the perfect stat because it's cramming stuff together. But the good news is you notice in that pile, well, it's the top of the pile, so it's a little bit skewed, but a lot of them are thin individual boards and not sandwiches. And that's good because that means we caught it early in the testing phase. But this was late in the process, so you see some of the sandwiches on top. But by and large, I think we only had like 5 or 6, less than 10 sandwich ones bad, which is really good because that means the testing early on was worth it. If we would have wasted so much time on all those single panel boards, putting them all together just to find out that something we should have caught earlier was wrong. Batteries, Aaron got about 64 pounds of batteries shipped to his house. And when I opened the box, I thought it was really pretty, so I had to take a picture of it. Satisfying looking.
It was fun to pick up off the front porch after it got delivered, I'll say that.
Yeah. So a few more assembly photos as they were starting to stack up as we were finishing them, and then we had to put batteries in, and we did a final test. It was a debate if we had time, to actually put batteries in and power every single one on. Ideally, that's something you want to do, but when you're racing against the clock, you just trust that those other testing early on caught most of it. But we ended up deciding it was probably best to do that. So every single badge we touched and put batteries in. It wasn't all serious business. Cats got involved at some point. Couldn't help themselves. And so, yeah, we finished with 3 days to spare, actually, which was good because, getting them stuffed for the conference is, a physical conference is easier, right? Especially in other times when you can get 10, 15 people together, set up a huge assembly line and start jamming all these, conference bags together. But when you're shipping things and you don't necessarily want to get, if you're trying to social distance as best you can, we wanted to make the 3 days to spare was good because we wanted to make sure Dan and his family, who stuffed all of our bags and shipped everything, had more time because, our hell kind of just ended, but theirs was just beginning. So we wanted to give, not pass the buck along. So some closing thoughts. I guess we should have said this in the beginning. Like, neither of us are professional electronic engineers or anything. We're just curious people that will, devote time to things that we find interesting. So if you have interest, you can totally do it. Electronics are really just adult Legos, and the data sheets are the instructions. Like, it's all out there, how things need to be connected, what type of protocol is what, like, it's all out there. And if you're interested, you can totally figure it out. If you have questions or whatever, I know I can only speak for myself. I'm sure Aaron's probably in the same boat. Reach out and we can try and help things through. That's where, we really like the Hardware Hacking Village because we can kind of meet with people and answer questions, but we'll just have to see you next year. And on a final note, I'll say, if you have any issues with your badge, please bring it to Kernelcon2021, bring it to the Hardware Hacking Village, and we'll either fix it or replace it for you. As you just learned, our process was heavily accelerated this year, and so it was in a hurry, so things might have slipped through the cracks. So, but we're more than happy to fix anything that we messed up. So,
yep, definitely.
That's it.
Do you want to mute and I'll ask a question?
Sure.
We'll go. All right, until you're ready. All right, this is going to be a little interesting because we're going to have to mute and go back and forth here, so we don't have a lot of interference. But we do have a few questions. First of all, I think I can say on behalf of all of the attendees, thank you, both of you. This badge is incredible, awesome, good work. And
you're muted.
Oh, I'm muted. Holy cow! All right, unmute. There we go. This is amazing. Mute works. So this is gonna be interesting because Tyler and I are in the same room, so we're gonna be doing some mute unmute game here. Hello. I want to say on behalf of all the attendees that you guys did an awesome job. Incredible badge. Thank you so much. Oh, I'm still on mute. No, yeah, I am. It's blinking. All right. Third time's a charm. I think I'm totally not on mute right now. Tyler and I are doing a mute-unmute game because we're in the same room, and it's a little bit tough to get it right. Also, it's been a long couple of days. But I want to say on behalf of all of the attendees, thank you so much, guys. That badge is incredible. It is awesome. You guys did a ton of work. And we do have a couple questions. We're going to go through them kind of quick before we get to the Own the Con. Personally, I thought the DIY Pogo clamp was unique and pretty awesome. We had a couple of comments on that. Somebody asked, what size are those Pogo pins?
Sorry, I had to unmute. That's really distracting to hear my own voice. I'm actually not sure. I don't know the specs off the top of my head. It fits in the standard size like hole that's in PCBs, so the same as like what a header could go in. I can post the Amazon link in the badge chat later to those Pogo pins. They come in different sizes, so I got one small enough that would fit into the prototype board I had, the kind of perf board. I got ones that were small enough to go in there, but they come in all different sizes. So, you know, I can link in the badge chat.
All right. Got another question on mute. All right, and one more quick question. Oh, interference.
Oh, sorry.
There we go. What happens to the failed and bad boards? Can they be recycled at all or reused or anything?
I still have a box of last year's actually somewhere.
Yeah. They kind of just sit in a box. Something that I just thought of that could be interesting. We could maybe bring them to the hardware hacking village for next year and be like, can you figure it out? And, you know, everyone can take part in the fun debugging. And if we hurt them any farther, it's no big deal. And that could be interesting. We can all learn from that. So that's actually, I'm glad you asked that because that seems like a good idea. You can take parts off, like with the hot air, like I showed you how we took those buttons off and fixed them. So you could take parts off of them, but now they got solder on them and you run into complications. So unfortunately, there's not a ton you can do. I'm not aware of anybody that recycles them outside of, you know, kind of standard electronic recycling where they just grind stuff down. But that's the answer I got for that one.
We'll wrap up here. All right, I think we're out of time now. Appreciate all the questions. I know if there's more that you can hit up Tyler and Aaron on Discord. So that's the last of the talks for Terrified Chipmunk. Up next is Own the Con in just a few minutes. So we'll get ready for that and we'll see everybody there. Thanks, guys.